I was a little bit nervous because each time when we, run this workshop, I'm not afraid. I'm afraid that maybe there's something wrong with SPSS, right? Because I installed SPSS on my desktop. It works perfectly, but here I think it works on a different system, okay? So I think it might take a little bit time for you to open it, but don't worry, we have plenty of time, okay? All right, okay. So, all right, we're going to start. So you can actually access the PowerPoint from the shared folder. Okay? Yes. Before you have the hands-on SPSS, practice, and I would like to review some important statistic concepts we learned last Thursday. Okay, and we'll learn maybe just a few more new concepts. Okay, I think it is important for you to understand the rationale, of some important concept. Okay, before you do the practice. Okay. All right. So we're going to review. First, review some basic, important statistic concepts. And then afterwards, I'm going to show you how you can conduct like t-test, independent samples t-test, and pair samples t-test. Okay. Do you still remember the difference between the two? So when should you use independent samples t-test? When should you use paired samples t-test? Do you still remember the difference? Do you still remember the difference? So independent samples t-test, that means each score comes from a different participant, right? So each score is independent from each other. So in this case, usually we see an experimental group and a control group, right? So we compare the performance between the control group and experimental group, right? So in this case, we have to use the independent samples t-test. Now, when should we use paired samples t-test? Do you remember? When there's only one group, but they have to be tested how many times? Twice. The pre-test and post-test, right? If you want to compare the difference between the pre-test and post-test, then we use paired samples t-test. Because each score is from the same participant. There are two scores, right? From the same participant, right? So paired samples. Right? Pre-test and post-test. In the sense they're paired, right? From one student, okay. And when should we use ANOVA? Remember? Where you have more than two groups, right? For example, in the experimental design, you have maybe one control group and two experimental groups, or maybe like even 3 or 4 experimental groups, right? So you have at least 3 groups. Then you use ANOVA. Okay. But ANOVA, we just focus on the between subjects ANOVA. What does it mean? So that means each participant will be measured once or twice? Once. That's right. Okay. And correlation. So I think I didn't introduce this to you last time, but I think it is an important concept for you to know. Correlation, can you give me a synonym to correlation, to the word correlation? Yes? Correlation means what? Yeah, relation. So relation between what? I think last time we mentioned one important concept, variable, right? So when we talk about a relation, a correlation, it means relation between how many variables? At least 2 variables, right? Okay. So how do you think that some variable can relate to each other? In what sense? Now think about, for example, like age and language proficiency. Do you think these 2 variables could correlate with each other? In what ways? Maybe the older, the bigger your age, maybe it's possible that the more proficient your language is, right? But it really depends, right? Because we all know that at a certain level, we're going to stop. We don't make progress anymore, right? But when you compare like age, for example, between 6 to 20, maybe you can kind of see quite clearly, right? Oh, someone who's older tend to have a higher language proficiency rate than those younger. Okay, so correlation actually will measure this kind of relation between at least two variables. Okay? Statistical methods. I try to simplify it because it could be very complicated. Actually, today we just focus on two types of statistical methods: descriptive statistics and inferential statistics. As you can see that the two terms are different, right? Descriptive, it means that it's a kind of statistics that you're going to describe what? Describe the data you've got, right? Okay, so describe. So for example, you can provide what? What information do you think usually we provide for descriptive statistics? Think about what you learned last week. You describe the data set. So usually pick up some values, right? So what kind of value will you pick up? Like what? Like a mean. Like mean standard deviation, right? You describe your data set, right? Okay, that's right. But inferential statistics is different. Inferential. So do you know the meaning, inferential? This word comes from infer, right? What does infer mean? Guess, right? So that actually you can see that inferential statistics is more than descriptive statistics. So when the information provided in inferential statistics can help you to make guesses about the data. For example, you compare two data sets, one by the control group, the other by the experimental group. Actually, you can see which one is doing better, right? So you kind of predict. So when we talk about inferential statistics, often it involves using statistical tests, such like t-test and ANOVA test. Okay. Okay, so descriptive statistics, is used to summarize large volumes of data to provide the reader with an understanding of what the data look like by using a few indicative and typical values. So can you give me some examples of indicative and typical values? So what are the indicative or typical values in the data set? Typical, that means what? Maybe it may occur quite a lot, right? Typical, right? It's frequent, right? Okay, all right. Okay, so maybe let's start from observing some data sets. For example, at the bottom is kind of a histogram. So do you understand what it means? Do you understand what it means? For example, For example, like when you see the value 73, so 73 is a value here, right? Okay, and then it corresponds to 1. What does it mean? It occurs only once. There's only one value that is 73, right? Okay, now same for 72, right? What about 70? 2. What about 69? 4. 67, 3, 65, 1. So actually, by looking at this kind of histogram, you kind of know how many values are there, right? So you simply add, for example, 165, and 66, and then 367, right? So you can calculate how many values are there, right? Okay. So which one do you think is most typical value? What do you think? Typical value, indicative value. So which value? In this case, perhaps is 69, right? It occurs 4 times. So the mean is the average of all the values, right? The mean should center around 69, right? Is that right? if you calculate the mean, I think it should be 69 plus or more, less. Just slightly less than 69, or slightly more than 69. I think actually it should be slightly less than 69. Okay, if you calculate the mean, right? Okay. So this is the information you can get, for like a data set. If you present information in this way, it's called histogram. Okay. Maybe let's look at this. This actually, you can see that it presents information for the sales for different IT products, right? So from January to June, okay. So the blue line means there's sales information for desktops. The orange line for laptops, and the gray line is for tablets. Okay, so observing this figure, a graph, what information can you get? You can see that both, for example, tablets and laptops, generally, the sales, information is getting better and better, right? It's rising, right? For the desktop, it's dropping, right? Right? Okay? So actually, this kind of information, right? Okay. This is a different one. Look at this table. Tabular summary. Maybe it collects. What kind of information do you think this table collects? Maybe it collects, some participants' degree information, right? So it says that like 2 people, only got a high school degree, 7 bachelors, and 20 MBA, okay, and 3 masters, 4 law, and 4 PhD. So which one is the most frequent one? MBA. That's right. Okay, right? Okay. So descriptive statistics will, I provide you with this information. Okay. All right. Now let's come back. Maybe let's focus on the histogram. Remember the 69 and the 70, this kind of information, okay? Because if we do experiment, usually we're going to collect scores, numbers, right? Okay. Now what needs to be looked at in a data set is 2 types of information. Central tendency, do you understand? Central tendency, what does it mean? Central, so what kind of information is situated in the center, right? Okay, so for example, when you try to recall from the histogram, so what kind of information will be situated in the center? What kind of values? Usually the values closer to mean, right? Because they occur a lot, right? So actually when you talk about central tendency, we mean those like mean, those most frequent values, okay? This central tendency, okay? Now dispersion, do you understand the word dispersion? Dispersion means what? Can you give me a synonym? The distance between different values, right? So how different values, how values vary among them, right? For example, which concept should we use to refer to dispersion from what you learned last week? Standard deviation, that's right. Remember, standard deviation actually is the average of all the differences among all the values in the data set. So if you have a large standard deviation, what does it mean? So how does the shape look like? It's it's wide, right? If you have a very small standard deviation, and it's like that. So all the values will center around the mean, right? They're very close to each other. So you have this kind of shape, okay? It is too easy for you, or do you think it makes sense? It's okay? All right. All right. So when we try to look at central tendency, we look at the typical or most representative values in the data set. Usually it's a mean, but not only mean. I'm going to show you, 2 other, representative values, okay, apart from mean, okay. When we talk about dispersion, we mean the spread of the values around the typical values. For example, around the mean, right? How other values are close or distant from the mean, okay, right. So usually you represent data like a curve, right? Like a curve. The highest point usually should be the mean, right? Okay. Okay, now mean is the average of all the values, right? For example, okay, this is the kind of data set you're going to get. So here we have how many? 14 values, right? So how do you calculate the mean? It's very easy. You simply add all the values, and then you divide it by the total number of values, right? So you get the mean, okay? So actually mean is something that we in experimental studies, we should always, examine the mean in standard deviation, okay? Apart from mean, we may also consider other typical values. Mode. Mode is the value that appears most frequently. For example, in this data set, 2 values are quite frequent. 14 occurs 3 times, and 24 also 3 times, right? Okay. Now, where should we use mode? For example, like if you're going to describe the categorical data, like a grade, for example, how many students get A, how many students get B? Like in the first table we see, like degrees, right? Okay, so we use mode, okay? Now median. Median is another, well, it's not very important, but I think at least you should know what median is, okay? So median actually, again, is kind of value that will divide a distribution in half. So median is in the center. So in the median in the center, okay? So before the median, you find half value, half of numbers, and after the median, you also have half of the numbers, all the numbers, okay? For example, in this case, because we have 14 values here, right? So there will be 2 median, For example, so 24, actually should be the median because, okay, so it's in the center, right? If we have, for example, all the numbers, median should be only 1, right? It's okay? So it's not difficult to understand, right? Okay. But anyway, mean is more important, okay? Experimental studies, okay? Now, why do you need to know, for example, like median, mode, or mean, okay? Why do you need to know the difference? I'll give you a concrete example, okay? Like, as I said earlier, usually we will look for mean when we summarize the data. For example, the mean of monthly income of our class maybe is 15,000 Hong Kong dollars, okay? So it's hypothetical, okay? All right. Now, what would happen to the mean if Bill Gates joins our class? So the mean will be, will rise sharply, right? Okay, right. Now, what would happen to the median if Bill Gates comes to our classroom? The median perhaps it won't change a lot, right? Okay, so when there's serious outliers means some values which deviate greatly from the mean, okay? Then the median is more suitable to summarize the data. This is all you need to know about when you should use median, okay, all right? Or sometimes the easier way is we just delete the outliers, right? Okay, so that the data set will not be inflated, right? Okay. Is it okay? All right. So these concepts are easy to understand, right? Okay. Now let's start with a concrete example. So here we have 2 candidates. Maybe we decide, okay, maybe this school, this university decide maybe they're training, maybe one school are training 2 students. They're going to, they train them for half a year. They would like to send, choose only one candidate, maybe to represent to the whole school to compete for a prestigious, maybe like oral, like language competition, oral language competition, okay? Right, so these are the scores for the 5 mock tests in the past 5 months, okay? So January 19 for candidate A, okay, February, blah, blah, okay. Now notice that the mean for each candidate is the same, right? So I want to ask you, which candidate should we choose? Why? Because the standard deviation is smaller, right? So that means that candidate maybe will perform more reliably in a real test, right? Okay, so there's more chance of winning the competition, right? Okay, that's why sometimes even the mean is same. If the standard deviation is different, it can also give us different information, and we need to use this information to make our judgment. Okay. So as you have observed, you can see that The candidate A, you can see that the standard deviation is quite small, only 2.5. But for the standard deviation of the candidate B, you see it's quite large. You can see that data shape, right? It's much more spread out than the data of the candidate A. So if we choose, candidate B, what about if it performs badly, right? So there's great chance to lose the competition, right? Now I also want to ask you some more questions about how can we make use of the information of the standard deviation, okay? How can we imply, how to, for example, in mental study. Now suppose, okay, you pre-test a group of students, right? So the mean is quite low, and also the standard deviation is quite large. So it means that the difference, among participants is quite large, right? Someone maybe perform much better, and someone will, perform very badly, right? Okay. Now, after your intervention, after your treatment, you give them post-test again. So what kind of results are you expecting in terms of mean and standard deviation? In the pre-test, low mean and high standard deviation. So imagine, okay. Now in the post-test, so what kind of results will you expect? High mean at least, right? Higher mean, right? And what about standard deviation? Maybe smaller standard deviation. So actually in this case, it means, for example, like your method is effective, okay? It shrinks, it shortens the difference between individual. So that means maybe it's quite equally effective for all students. Is that right? For most of the students, right? Okay. Now what about, okay, if in the pre-test you got a low mean and a low standard deviation, and in the post-test you get a high mean and a larger standard deviation, what does it mean? It means, so pre-test, low mean and the low standard deviation, but in post-test, after intervention, after treatment, higher mean and a larger standard deviation, what does it mean? It means perhaps, so the method maybe is more effective for certain types of students, right? Not all students, right? So this is the implication of mean standard deviation, okay? If you have any question, you can raise your hand, okay? And ask me the question, okay? I remember I mentioned normal distribution, but I didn't explain, okay? Because you have to understand the mean and standard deviation so that I can explain to you what normal distribution is. So observe this shape. So can you describe the features, the essential features of a normal distribution? I give you more hint. So what does it mean? Mean, median, and the mode is the same value. Center, okay? And what other features can you observe? What other features can you observe? You just describe what you have seen. What?
The data distributed.
Yeah, in what sense? For example, around the mean, median, and mode, we can divide the bell, maybe it's a bell, that looks like a bell, right? Into two halves, right? So each half is symmetric, identical, is that right? Okay, so that's another feature, right? Okay, and also examine here, what does this mean? This actually means standard deviation. So what does this mean? So it means 60% of values, of all the values, will situate one standard deviation to the mean. Do you understand? This is one standard deviation from the mean. This is one standard deviation, the distance. Okay. So you got lost. So dispersion, okay. So that means that all the values here, you can see that these are all the values here, many values here, right? So that means 60% of values will be situated one standard deviation within the mean, you see? This is a one standard deviation larger than the mean, right? This is one standard deviation less than the mean, is that right? So in this area, it includes 68% of all the values, okay? And within 2 standard deviation, it includes 95% of all the values. And within 3 standard deviation, it will include 99% of all the values. So if these conditions are fulfilled, there's kind of a normal distribution. Is that right? All right. Usually if your data is large, it will be normally distributed. It's large enough. But sometimes when you do experiment, for example, like 20 or 30, it's quite difficult to reach kind of a normal distribution. Okay, but it doesn't matter. You can still use statistical tests. Okay. But anyway, okay, I just mentioned this very briefly, so you understand in future what does normal distribution mean. Okay. Right. Some statistical tests will require your data to be normally distributed. Okay, but well, even if it's not slightly not normally distributed, it's okay. You can still go ahead with, the statistical test like t-test and ANOVA. Okay. Okay. So, do you have any question regarding the previous part? I think the previous part is about descriptive statistics. So, any questions? No. Clear, right? Okay. Okay. So, before we talk about inferential statistics, again, I think we're going to repeat or kind of try to re-emphasize sample in the population. Now let's start with a concrete example. Now suppose you are a school principal, okay, and you have the scores of one standardized language test for all the students in the school. Now assume that EDB, Educational Bureau in Hong Kong, okay, will be arriving next week to give a similar standardized test to 100 randomly selected students. So why does EDB test all the students in your school? It's too time consuming, right? And you need lots of support of manpower, right? So you can only test 100 randomly selected students, right? Okay. Now your population, 1,000 students. So that's all the students in your school. However, you can only test 100 randomly selected students. So this actually is your sample. So you can see that in most experimental studies, we cannot possibly test all the population, right? We can only test selected samples. But how should we select samples? We should select samples as approximate as our population, right? Okay? But how can we do so, right? Random sampling is one strategy to achieve this, okay? Now, properly drawn sample will resemble the population from which it's drawn, right? Okay. Now, we need to make sure that the average test score of the random sample of 100 students will not deviate. Deviate, what does it mean? Deviate. Do you know the word deviate? Differ. Will not differ sharply from the average test score of all the students in the school, right? This is something we'll have to make sure, right? Okay. Now, in other words, the sample results scored of the 1,000 randomly chosen students are a good proxy, very similar for the results of whole population, the 1,000 students in your school. So we'll use this method. We just draw samples randomly from the whole population, right, and form a smaller pool, right, and we test this smaller pool. Okay. Usually, the sampling method, there should be 2 broader types. One is random sampling, the other is purposive sampling, right? But in reality, we have to understand that usually we use purposive sampling, right? Because, for example, like if you just do a student project, you don't have, money and support, to really, to make random sampling, right? You can only, for example, make use of your own students, right? So usually, actually we make use of purposive sampling. It's perfectly understand for student research. For example, like honors project, your MA dissertation, or even your PhD study, it doesn't matter. Most students will use purposive sampling. But random sampling would be required. For example, if you're going to apply for a high-stake, a very prestigious a grant, for example, like General Research Fund provided by Hong Kong government, it's very competitive and require you usually, if you want to do experimental study, they want to show that, for example, everything that you have a very rigorous research methodology. When I first applied for this grant, I suggest I only use like very small number of students, 15, or 30 students in experimenter group and 30 in a control group. You say, well, it's not enough. And then I'll only suggest to make use of students from my university. And well, again, this thing is, well, then later I revised. So I suggest I did use random sampling, but I will try to use stratified sampling to include participants from the 8 public universities in Hong Kong. And I increased my sample to 240. And finally I got a grant, okay? All right. So I think it's perfect, right? If you would use purpose sampling to conduct your student research, it doesn't matter, okay? Okay, now inferential statistics. So inferential statistics allows us to go beyond simply describing the data and ask questions about data. So what questions will you ask about data? For example, when you compare the data from 2 groups, is there a difference between the reading ability of the 2 groups, right? Okay, do you think, well, maybe group A will do better than group B, right? Okay. Or is there a relationship between participants' age and reading ability? Well, you kind of assume, there will be some relation between 2 variables, okay? So inferential statistics actually allow you to ask these questions and test what you have guessed, test your hypothesis. Okay. So when we see that we do inferential statistics, we're going to test your hypothesis. Do you know the word hypothesis? Okay. So inferential statistics will allow us to find information about population based on sample. Okay. So in reality, we cannot test all the samples, right? We cannot test all the population. We can only test some selected samples. So we have never tested our population. So what you can do is, based on the result of a sample, you try to make guesses about the whole population, right? Okay, is that right? Okay, that's right. So the process of using data obtained from sample to make estimates, to make guesses, and test hypotheses about the characteristics of a population. Okay, so that's why we need inferential statistics. So actually, it's kind of a process of making guesses. So questions we need to answer is how to make better guesses, how to control guessing errors. This is very important. Control guessing error actually is related to a concept we talked last time. I didn't explain to you what it means, which is p-value. Okay, to control guessing error. Okay. So hypothesis, prediction about the outcome. Null hypothesis. Usually, I think when you read articles which deal with experimental study, particularly in pure scientific study, there will be at least 2 hypotheses. One is null hypothesis. Do you understand the meaning null? Invalid. Invalid means what? There's no group difference. Compared to groups, there's no group difference. That means 2 groups will perform the same. Null hypothesis. Now, alternative hypothesis sometimes is also called research hypothesis. Actually, this is a hypothesis you would like to see, right? You would like to predict, to make true, okay? There's group difference. So now alternative hypothesis is also called research hypothesis, okay? So you carry out. Now I want to ask you this question. Which hypothesis are you more interested in? Which hypothesis do you usually expect to be true in studies? Null hypothesis or alternative hypothesis? Usually, I think we are more interested in so that alternative hypothesis would be true, right? Because we would like to prove that our method is more efficient. than the other method, right? So in our study, actually, we always try to look for an alternative hypothesis. We would like to accept alternative hypothesis and reject null hypothesis, right? So this is related to p-value. So how does it relate to p-value? P-value actually is the probability that a null hypothesis is true. Okay. So null hypothesis means there's no difference. So p-value actually means the probability of the chance that a null hypothesis is true. So do you think we expect a big p-value or smaller p-value? Smaller, right? The smaller the better, right? The smaller that means there's high chance to reject the null hypothesis and accept our alternative hypothesis or our research hypothesis. Okay? Is it okay? So I mean, actually, you can just use your logic to understand this. Okay? You don't need to understand actually, for example, the formula behind the p-value. Okay? Okay, just So we always need to look for a smaller p-value. Okay? Because of this, we try to reject the null hypothesis and accept our alternative hypothesis. Okay. P-value ranges between 0 to 1. Smaller p-value, especially those smaller than 0.05, indicates strong evidence to reject null hypothesis or accept alternative hypothesis. Okay. So that's why we always look for a p-value that is smaller than 0.05. It's okay? Now I understand? Okay, clear? All right. So usually a p-value smaller than 0.05 is what we wish to see in many significance tests. So what does significance test mean? Like t-test, ANOVA, these are called significance tests. But it's also broadly speaking an inferential statistical test. Okay. Okay. So we're going to, in the following session, we're going to cover these statistical tests. Between group t-test, independent samples t-test. Within group t-test, pair samples t-test, ANOVA, one way between subjects ANOVA, and correlation. Okay. Let's start with a real situation. Real, for example, like real. Okay. Well, this is not a real one. Still hypothetical. Okay. Okay. Now, for example, like in this study, we're trying to compare traditional teaching with media support. So a group of 45 students are randomly divided into two groups. One receive traditional teaching, and the other teaching with